So now we're with Dr. Rex Munday. He's the inventor and the man behind a lot of the research and development of the time capsule. Welcome, Rex.
Hi.
Now, why do we need a time capsule?
Well, I guess it's been known for about 30 years that zinc gives really good protection against facial eczema. And there's a lot of work being done on the dose levels that you need, how long you have to give it, how regularly you have to give it to animals to get the very best protection. So the research came up and it said the dose level is about 25 milligrams per kilogram per day. And it's best if it's given every day. And it needs to be given throughout the whole of the facial eczema season, which can be over 3 months. So really, in practical terms, to ask, say, a sheep farmer with 1,000 sheep running over the hills to dose every day for 100 days just isn't possible. What we needed was something that would release those amounts of zinc that give good protection every day over perhaps 4-6 week period. So the farmer would only have to dose once, twice in the facial eczema season, and he'd get the good protection that zinc can give.
And was there any technology available in New Zealand or around the world that you could tap into, or did you have to start from scratch?
Unfortunately, no, because there were and still are controlled release devices around, but these are designed to release milligram quantities of zinc. Now, as I said, the dose level we need is 25 milligrams per kilogram per day. So for a 40 kilogram sheep, you need a gram of zinc every day. So the devices that we could have access to, the commercially available devices, would release milligrams, but we needed to release grams, 1,000 times more. So there really wasn't anything we could use, so we had to start from scratch and invent something that would work here in New Zealand. And again, it wasn't any good looking overseas for anyone to do this for us, because facial eczema really is a New Zealand disease. It's not a big problem elsewhere. So we had to start and develop something that was going to give us the product that we wanted, to give us the correct amounts of zinc over a 4 to 6 week period.
So that's where you come in. Has it taken long?
Yeah, well, actually I've been working on this for 15 years. Now, we got our first product out, which was sheep and lambs, at about 8 years after the start. I mean, the whole thing was fraught with difficulties, actually, because we are trying to release a lot of material. We also wanted to make it cheap. It's no good to have something that nobody can afford. And also we thought it'd be better if the bolus disappeared completely after its zinc had gone. A lot of the devices that you can buy can contain plastic or metals, and they can cause a lot of problems at the freezing works. So what our objective was at the beginning was to have a bolus that lasted 4 to 6 weeks, released 25 milligrams per kilogram per day, and disappeared completely. So we started off with some really good ideas, which failed absolutely. And eventually we came up with what's now the time capsule, which looks like this.
So effectively starts eating away at the top and works its way down.
Well, here you see an X-ray of a sheep, and it's got a time capsule in its rumen. You can see here's the time capsule, shows up really well on the X-ray. And this is a bolus that's just been put in. So this is a new one. You can see it's square across the end and it's long. Now, if we take an X-ray 2 weeks later, what you see is the bolus has got smaller. And here it is after 2 weeks. And you can see that the bolus has just got shorter. So in 4 weeks, that's another 2 weeks after that, the bolus really does get very small. Here it is again. You can see it's gone about 2/3, I suppose. And in another 2 weeks, that will have disappeared completely. So here we have a bolus that disappears over 6 weeks. This is a sheep bolus, which will give you protection for a 6 week period.
So is that the same with cows as well? Because we talk about 4 to 6 weeks cover, don't we?
No, for the calves, the boluses disappear in 4 weeks. So you get 4 weeks where the bolus is in the animal, but it will disappear over 4 weeks. You get 1 week extra carryover of protection. So in a calf, you get 5 weeks protection.
Now, you've obviously done a lot of work to prove that it works. Why don't you show us some of those results?
Yeah, here's the data from one experiment we did a few years ago, in which we took 2 groups of animals, the 2 groups of sheep, one of which was given a bolus, the other one was left untreated. And we ran these together in a paddock which we knew contained a lot of Pithomyces spores. So the animals would be really very much at risk of developing facial eczema. And what we did was to measure gamma-GT. It's an enzyme which is in the blood, and it indicates the degree of liver damage that the animals suffer after they've been exposed to the poison, Pithomyces poison. So we took a blood sample from the animals and we measured this enzyme in their blood each week for 7 weeks after they were put onto the hot paddock. So what happens is that it takes a little while for the toxicity to become apparent in the animals, about 3 weeks. So if we look at the animals, the control animals first, the ones that didn't have the bolus. Now here's your normal gamma-GT down here at about 30 units per litre. What happens after 1 week? Not very much at all. 2 weeks, still not very much at all. 3 weeks, just starting to shift a little bit, just coming up a little bit. But after 4 weeks, when the poison really is taking its effect, this thing starts shooting up. Really bad 5 weeks, 6 weeks, getting really quite serious, tailing off a little bit afterwards. But what we're seeing here with a gamma-GT of 600 is that is a really severe challenge. These animals were really suffering from the facial eczema. So, yet we'd got a really good challenge there in these animals. They were all affected by eczema. And so, what did the bolus do? So, let's see what happened with that. And here, again, it started off okay. 2, week 3, again, nothing happening. Now this, of course, was the crunch time. What happened at week 4? And we had a few celebrations here,
yeah, of course,
because that was really good. There's virtually nothing happening at week 4. A little bit week 5, a little bit at week 6, turning down again. Look, we had about 90% protection here, so yeah, we had really good celebrations. This is what makes science worthwhile when this sort of thing happens.
15 years worth, you mean?
Yeah, brilliant, yeah. I mean, it made it all worthwhile when you get results like this, because we knew we'd got a product then that worked. We knew it was practicable. We knew we could make it in large numbers. We knew it was cheap. And this is what made it all worthwhile. When you see results like this, whoopee, really good.